Alright, in this lesson we need to look at some things that you have to know before you can do coordinate proofs. The first thing we're going to look at is the distance formula, and this is something that you've probably seen in the past. The distance between any 2 points is given by the formula d equals the square root of x2 minus x1 in parentheses squared plus y2 minus y1 in parentheses squared. That formula is on your formula sheet, so you don't have to memorize it, but you do need to make sure that you know how to plug everything in correctly. For our first example, we're going to look at finding the distance between points A and B, 3, -2, and -4, 5. One thing to pay attention to is a lot of times you'll see with the distance formula, if we're finding the distance between 2 points A and B, we'll just put those 2 points with no bar over it. So if we put the bar over it, remember that means the segment AB. But if you just see 2 capital letters next to each other, that tells you that you're looking for the distance between A and B or the length of segment AB, but it's definitely a distance. So when you see that, that's what it's asking you for, is the distance. Alright, so we need to plug it into our formula, x minus x. So in this case, our x coordinates are 3 and -4. So 3 minus -4. We'll put that in parentheses squared, plus our y coordinates. Now this is where I have to pay attention to the order. I put the 3 first here, okay, and the 3 was in point A, so that means I have to use the y coordinate from point A when I plug it into the formula first. So I have to put this one as -2 minus 5. So it doesn't really matter which one you put first for your x's, but it matters that when you plug in for your y's that you go from the same ordered pair that you started with. Once you get it plugged in, the next easiest thing to do is to just take that and punch it into your calculator. So we're going to put in the square root, parentheses 3 minus -4, and then we'll close our parentheses squared, and then plus parentheses -2 minus 5, close parentheses squared. And I left off a parentheses. Let's go back and add that in. Alright, so I'm going to insert a parenthesis there. Alright, hit enter. And our distance is 7 square root 2, which is approximately 9.9. So 7 square root of 2, or about 9.9. So AB square root of 2, or approximately 9.9. Alright, so try this one on your own. Take a second and pause the video, and then punch that in your calculator, and then restart the video to check your answer. Okay, so hopefully when you plugged it in, you got that the distance was 3 times the square root of 17, which is approximately 12.4. The other thing that you need to know for this unit with coordinate proofs is the slope, and you probably just used the slope when you were looking at your packet on parallel and perpendicular lines. But just in case to refresh your memory, the slope of a line passing through any 2 points is given by y2 minus y1 over x2 minus x1, also known as rise over run, or the change in y over the change in x. A couple of other things you need to remember about slope. If lines or segments have the same slope, they are parallel. If lines or segments have slopes that are opposite reciprocals, and remember, opposite means different signs like positive and negative, and reciprocal means you have a flipped fraction like 3 over 2 and 2 over 3. So if you've got opposite reciprocals, your lines are perpendicular. If they're not the same and they're not opposite reciprocals, then the lines are neither parallel nor perpendicular. So in this example here, we need to find the slope of 2 different segments. We need to find the slope of segment AB and segment BC, and then compare those so that we can classify them as either parallel, perpendicular, or neither. So I'm going to start with AB. So the slope of line AB, or segment AB, just plug it in my rule, so y minus y. So for this one, I'm going to start with point B. So 2 minus the y-coordinate of A, which is 1, over the, and since I used the y-coordinate for point B, I have to use the x-coordinate for point B on the bottom first. Then negative 2 minus 2. Alright, if I punch that in the calculator, or I can just work it out in my head, 2 minus 1 is just 1. And then minus 2 is negative 4. So that gives me a fraction of negative 1/4. Alright, the next thing I need to do is to find the slope of segment BC. So the slope of segment BC, just apply the formula. So I'm going to take the y-coordinate of one of the points. This time I'm going to start again with point B. So the y-coordinate of point B is 2, and then I'm going to subtract from that the y-coordinate of point C. And again, since I started with B here, I'm going to start with the x-coordinate for B on the bottom, which is negative 2, minus 1. And again, we can punch that in the calculator, or you could just work it out in your brain. So 2 minus negative 2 would be positive 4. And then negative 2 minus 1 is negative 3. So I end up with negative 4/3. So if I compare those two fractions have the same sign, but the fractions are not the same. So that means these are not parallel and they're not perpendicular. So these would be neither. Alright, and again, if they had come out to be the same, if they were both negative 1/4, then the lines would have been parallel. Alright, you might be asking yourself, why do we need to know the distance and slope for coordinate proofs? Well, in coordinate proofs, you're going to be showing that segments are either the same length, if you're going to try to show that, for example, that a quadrilateral is a rectangle. We know that rectangles have opposite sides that are congruent, so we would want to show that. And we can do that with the distance formula and the coordinates that were given for the vertices of the rectangle. The slope, again, if we were trying to show that a quadrilateral was a rectangle, we would need to show that the vertices formed right angles, or that the two segments that were consecutive formed right angles. Well, remember, perpendicular means that the lines intersect to form right angles. So if we show that the segments are perpendicular, then we've shown that they have right angles. And again, that would help us out when we're trying to show that we have a rectangle. Alright, hopefully this was helpful for you. If you got any questions, make sure you ask.